I'm Sophie, and this is my black hole lab. So, to outline what I'll be doing, I'll go over the purpose of the lab, some physics terms to know beforehand, coding for part one, the results of that, answer the question of what does it mean, coding for part two, the what if question, and then any potential errors I have. So, the purpose of this lab is to estimate the mass of the black hole using the results from the coding that I did for part one. And then for part two, the ship flies around the black hole, and I have to find the initial velocity so that the planet doesn't crash with the ship or the black hole doesn't attract the ship. So some things to know, Newton's second law, F equals ma. We can derive that term with the momentum principle to get that F net is change in momentum over change in time. And momentum equals F del t, which I'll use in my delta t, which I use in my coding. The gravitational force equation will also derive for the coding. The constant is already put in there for code, and unit vector is vector over magnitude for the direction. Part one of the coding, we have the gravitational constant, the mass of the star. The time I used was the amount of seconds in a day. And then for P initial and P final, I just used mass times velocity, which is the formula for momentum. I used velocity update formula and momentum update formula for delta V and delta P. For the unit vector for P hat, we have a P final over the magnitude of P final, which is just the typical formula for a unit vector. We have parallel change in P, which we know beforehand that F net equals delta P over the parallel force. The F net formula is F net minus F net of parallel. And then for the mass of the black hole, we just derived the gravitational formula. Okay, part one of the mass of the black hole, I was able to get that F net is 9.0 e to the 28, and then F net parallel is 3.8 e to the 27, F net perpendicular is 9 e to the 28, and the mass of the black hole is the average of all the data points from the code, which is 1.5 e to 34 kilograms. The purple arrow here represents P hat, the orange arrow is N hat, and the teal arrow is the net force. So what does this mean? So how the net force and its parallel and perpendicular components are different from the rate of change in momentum is if net force is equal to the rate of change in momentum and the parallel and perpendicular components coordinate with one another, then we're able to calculate the net force of a black hole simply based on the motion of that object, which is how we derived F net from the momentum formula. Part two of coding, this mass of a black hole is what I calculated in part one. The time I use, I multiplied it by 3 just to speed up the process. The planet's speed and velocity. And then I have the ship speed, trial and error, which is what I did in order for the ship to not go into the black hole or to hit the planet. The force on the planet by the black hole using the gravitational formula. Same with the planet by the ship, and the ship by the black hole and the ship by the planet. And then we use Newton's second law, F equals ma, and the momentum to do P equals F delta t for planet velocity and ship velocity. For the next picture, you're going to see that the planet is cyan and the spaceship is the magenta color. So here we see that the spaceship, within one revolved of the planet, it doesn't run into the black hole or the planet. Okay, so what initial velocity would your spaceship need to have in order to enter into some kind of orbit around the black hole? So for this, I just guessed and checked with the speed for X and the speed of Y of the ship. But I noticed that the planet's orbital speed, I just had to make the ship speed faster than that in order for the ship to not crash into the planet. In conclusion, we use the momentum principle and Newton's second law to derive out a formula for F net. I use the gravitational force, and any potential errors that I have is there's no human error in this lab because it's coded by a computer. Part one, I could have used more data points in the average of the black hole mass to get it more accurate. And for part two, I could have tried to get my ship closer to the black hole without it getting sucked in and tested more values.